Eric the Turf Teacher Jones. Oh, yeah! Teaching you life lessons, business strategies, and leadership.
Let's grow together.
Hey everyone, Turf Teacher here. Welcome to the course entitled Turfgrass Calculations with the course number of 2664. This course will get you 1 landscape credit for your North Carolina Landscape Contractors license for the renewal period of July 31st, 2025. Now, please note that this was a webinar that we did recently for pesticide credits, but it is not available for pesticide credit in an online format. We can only do those in webinar or live face-to-face. So, however, you will receive 1 landscape credit for your NCLCLB license up to July 31st, 2025. So please watch the lecture and then answer the 10-question quiz, and you'll be able to download your proof of attendance. Thanks, guys, and I will see you in the next lecture.
We are going to get started with this Turfgrass Calculations. And so the Turfgrass Manager, every single day, we are confronted with math problems, and a lot of people don't like that. It kind of scares them a little bit. I actually enjoy a little bit of, I don't know, maybe call it confusion or it's just the thrill of numbers and actually working through some of these application problems. I think overall as an industry, we probably, are not doing as much math as we probably should be. We're not calibrating our equipment as much as we should be. So, as much as these chemicals cost and how environmentally friendly, our customers want us to be, we probably need to pay more attention and actually work through some of these problems. And so when a mistake is made when calculating the number of ounces of pesticide to add to a spray tank, it can either in a major disaster, whether we've applied too little or even too much, both can hurt the checkbook. If we apply too little, we're going to have to go back because our customers has paid us for a visit and we did not take care of the pest. If we apply too much, again, we're spending money. If we did too little, we're having to go back a second time. We're probably going to throw a little extra in there when we shouldn't. So we need to calculate it and do exactly and put out exactly the right amount of chemical in each application. And so we need to develop these necessary math skills. And practice makes perfect. Just going over this stuff, even reading through our core manual and our ornamentals and turf manual, it's good to visit some of the math problems that they have on there. And if you've taken the test recently, I think I did it first time like in 98, and then I had to go back and get my E classification. And I did that 1 year to Green and Grow. It was right before COVID. So it might have even been 2020 that I took it again. And it was basically the same test that I did in 98. So but it's good seeing the math problems on there. There's very few math problems on the state exam. And so I think we do need to spend a little more time with it. And so when solving problems, your answers should always be double checked. And so we're going to go ahead and get started with math problem number 1. The turf manager wants to apply a 10-5-5 fertilizer at the rate of 1 pound of nitrogen per 1,000 square feet. And you're going to see that label rate, pretty much on a lot of things that we do. Everything is calculated in those 1,000 square feet. And that's why I like taking whatever my problem is. If we have like an 8,000 square foot lawn, I still want to know what it is per 1,000 square feet. And if you do your math at the beginning of the year and you know what each one of your chemicals is per 1,000, it's real easy to do quotes, estimates. It's real easy to do your invoicing, how many square feet that you've done. It's a matter of figuring out what it does cost you. And so how many pounds of this fertilizer should be applied per 1,000 square feet? And so there's a couple different ways that we're going to work this one. I'll show you both. I like one a little more than the other. and I'll show you which one. But we'll start, I think, with what's a little bit more difficult right now. So we'll make sure that I can draw here. We have 0.1. We have our 10% X is equal to 1 pound of nitrogen per 1,000. M represents 1,000, Roman numeral. So we're going to solve for X. Well, we think we are, yeah, so we're solving for X, pen cut off. And so we have 1 pound, 0.10. That's basically going to end up being 10 over 1. So we have 10 pounds. So maybe a little weird working it out that way. I think it's easier if we go ahead and did the 10 over 100. Solving for X, 1 pound. 1 pound of nitrogen over X. We get 10X equals 100. X equals 10. Easier enough to do that. And so are you guys able to see the blue handwriting?
Yes.
Yes.
All right, good deal. Good deal.
Yeah.
So do what, sir?
I
If
was
any
just saying,
questions-
I can see it. Thank you.
All right, and see, let me go ahead and open up the chat box. That way, if anybody can type in there, if they've got any questions or whatever, or you can raise your hand, or you can just, turn your mic on and start talking. So problem number 2, using the previous information from problem number 1, we're going to determine how much it will cost to fertilize an area that is 200 feet long by 90 feet wide at the rate of 1 pound of nitrogen per 1,000. Each bag of it is in 50-pound bags, and it costs us $20. And so we have 20 feet by 90. We're going to say 200 times 90 gives us 18,000 or 18 M in the Roman numerals. And we know that the 10 over 100, 1 pound of nitrogen over X, we have X equals 10 pounds per 1,000. Got our 10 pounds per 1,000 times 18,000 gives us 180 pounds. Well, we got to do the 180 divided by the 50 next. Gives us 3.6 times the $20 a bag. So it's going to cost us $72. And saving this, as soon as the class is over, I can email you all these problems, and it should save all of the math problems there on it.
Eric, do you save when you save it? Do we see all this that you've written?
Yeah. You should be able to see all of the blue handwriting that we've done. Yes, sir. Yep. All right. Problem number 3. It is stated on a 36-pound bag of 26,812 fertilizer that the bag covers 10,000 square feet. Typical rate right there. One bag will cover 10,000. You may see it cover 12,000. Sometimes you might see even a 14,000. But the turf manager must determine what rate of nitrogen per 1,000 is being applied if the spreader setting recommended is used on the bag. So we have a 36-pound bag. And we got the 26 there times 0.26 gives us, oops. We multiply that, we've got 9.36 pounds of nitrogen per bag. I'm going to go ahead and round that up to 9.4. And then if we're doing it, we got to take that number right there, the 9.4, which is pounds of nitrogen. We're going to divide it by 10. We're going to do 0.94 pounds nitrogen per 1,000. with the recommended setting. Problem number 4. Before seedbed preparation, the turf specialist sends a soil sample to a laboratory analysis. The soil test results indicate that 2 pounds of phosphorus should be incorporated per 1,000. He has a triple superphosphate 0460 on hand. The site contains 12,470 square feet. How much superphosphate is needed? All right, so we have 12,000 point, well, $12,407 So we write that a lot. You know, it's 12,470 square feet. You can do 12.47 M for 1,000 representing it and the numbers. And we're going to multiply that. Oops. Now let's take it back a step further. Sorry, I'm jumping ahead. We're going to start out with our 46 right here. 46 divided by 100. We've got 2 pounds of our superphosphate or our phosphorus. We're going to solve for X. 46X equals 200. X equals 4.3, which will supply us 2 pounds, or the 12.47 times 4.3 gives us 54 pounds. 12.47 times the 4.3, 53.6, 54 pounds would do the job. Problem number 5, an extension bulletin recommends applying an organic fertilizer 600 at the rate of 20 pounds per 1,000. How much nitrogen would be applied per 1,000? So simple here. 20 pounds times the 0.06. 1.2 pounds of nitrogen per 1,000. Problem number 6. On the label of a gallon of 2010 liquid fertilizer, it states that the gallon should be applied to 5,000 square feet. The label also states that the gallon of liquid fertilizer weighs 9.6 pounds. How much nitrogen per 1,000 will be applied if the recommendation is followed? So we have 9.6 times 0.20. This is 1.92 pounds of nitrogen. We're going to divide that by the 5,000 square feet. This is 0.38, round up to 0.4 pounds nitrogen per 1,000. Problem number 7. A fertilizer label states 24% total nitrogen, 6% water insoluble nitrogen. What percentage of the total amount of nitrogen is in slow release? So basically, all we're going to do is 0.06 divided by 0.24. And that is going to be 0.25, 25% slow release nitrogen, dividing the 6% by the 24%. 4 go in there. I mean, 6 will go in there actually 4 times. So basically that is the 0.25 or 25%. Problem number 8. So we're going to try to figure the price of 2 different products. The turf manager wants to fertilize at the rate of 1 pound of nitrogen per 1,000 square feet. She is considering 2 products. One is a 3300 that comes in a 36-pound bag and is priced at $18. The other is a 25.5 sold in a 50-pound bag costing $24. Compare the cost of the 2 products. So we got product number 1. Product number 1, we do have the 36-pound times the 0.33. That gives us 11.9 pounds nitrogen. Product 2 is basically the 50-pound bag times 20%, gives us 10 pounds of nitrogen. So actually the next one, nope. And so if we're going to figure out our cost, the first one up here, running out of room to write, so it's going to cost us the $18. I'm going to say $18 divided by 11.9 pounds. It's going to cost $1.51 per square foot. The next one, it cost us $24. And we're going to divide it by the 10. Is this the, and we're doing it by the M, 11.9 thousand, or 11,900 or 10,000. That gives us the 2.4 per square foot. So the first one, this one right here is better priced. Costing us $1.51 per square foot to do the job. All right, problem 9. A sandy loam soil has a pH of 5.2, and the turf specialist wants to raise the pH to 6.5. He consults a liming recommendation chart and finds that approximately 50 pounds of limestone per 1,000 square feet would increase the soil by 1 pH unit. How much dolomitic lime is required per 1,000? So first thing we got to do, figure out how much we want to raise it. So the 6.52 minus the 5.2 is 1.3. 50 pounds times the 1.3 gives us, we need 65 pounds. Problem number 10. An extension agent recommends applying 100 pounds of limestone per 1,000 to raise a levy of clay soil by 1 unit. The present soil pH is 5.8 and the desired pH is 6.5. The area contains 63,000. How much limestone is needed? Doesn't sound right. So again, we got to figure out what we're going to raise it to. So the 6.5 minus 5.8, we're raising it 0.7. We got 100 pounds times the 0.7. We need 70 pounds of lime to raise it. Well, 70 pounds per 1,000. And so we have 63,000 square feet. I got the 70 pounds per thousand times 63,000, basically 4,410 pounds of lime. So several bags. Problem 11, an area 30 or 300 by 150 is to be top dressed with 25 inches of sand. How much sand is needed to place a 1/4 inch layer of top dressing on it? So the first thing we got to do is get our square feet. 300 times 150 gives us 45,000 feet squared. And we are going to cover it with a 1/4 inch. So this gets just a little bit tricky. So we got a 1/4 times 1/12 gives us the 1/48. We're doing 0.25 inches. So an inch is the 1/12, and we're doing 1/4 of that. So we got actually the 1/48. We take our 45,000 square feet times 1/48 is 937.5. I'm going to go ahead and round this up to 938. And that is in, so we got 0.25 inches. This gets it converted to actually a feet. So that gives us the cubic feet. We divide by 27. And then we know that that's going to equal, so 938 divided by 27 is roughly 34.7 or 35 yards to do the top dressing. Problem number 12. A golf course superintendent plans to build a 2,000 square foot tee. To elevate the tee and establish a desirable root zone, he decides to place a 9-inch layer of sand over existing soil. What will be the total cost of the sand if the price per cubic yard is $15? So we have a 2,000 square foot tee, 1,000 square foot times 3/4, 0.75 feet. Getting that into cubic feet. So I have 1,500 cubic feet. Divide by the 27. We got 55.6 yards, cubic yards. And then we're just going to multiply that. We'll go ahead and make that 56 times the 15. So we're getting what? $840 for the total cost. Just in sand. Problem 13, a landscaper intends to improve soil structure by incorporating compost. The instructions from the provider recommend using 4 cubic foot bale per 200 square feet. The price of the bale is $10. The site is 60 feet long, 50 feet wide. How much compost will be needed and what will be the cost? So 2 different little math problems within it. So we're going to go ahead and get our square feet, 60 times 50. We got 3,000 square feet. Square feet. And we know that one bale is going to do 200 square feet. So how many bales? We're going to solve for X over 3,000 square feet. So 200 into 3,000 is basically 15. Do the cross multiply. 200x equals 3,000. X equals 15 bales. They cost what? $10. So $150. $150 for 15 bales, and it's going to cost us $150. Problem 14. A growth retardant costs $200 a gallon. The recommended application rate is 1.5 pints of growth regulator per acre, 43,560. What is the cost of the chemical per acre? So we're going to set this problem up. 8 pints, $200. Is equivalent to 1.5 pint x 8x equals 300 x. We're solving for $37.50 per acre. Problem number 15. A gallon of herbicide costs $90. The recommended application rate is 2 ounces per 1,000 square feet. How much does it cost to treat 1,000 square feet? So, got 128 ounces. So many fluid ounces in a gallon. We got a gallon. It cost us $90. Setting that up over 2 ounces. Over X. Solve for X. 128X equals 180. X is equal to $1.41 for 1,000 square feet. Problem number 16. We have a 5-pound container of fungicide that cost us $80. The material is a wettable powder. And the recommended application rate is 3 ounces per 1,000 square feet. How much will it cost to spray 8,500 square feet? So 3 ounces per 1,000 times the 8.5 or 80. Let's just do 8,500. Gives us 25.5 ounces. It is 80 ounces, $80. Got our 25.5 ounces. $80x. Multiply those out. You actually get 2,040. X is $25.50 to spray the 8,500. Problem number 17. A turf manager has a choice between 2 granular herbicides. Herbicide A costs $33.50 per bag, and it'll treat 18,000 square feet. A bag of herbicide B costs $25.95, covers 7,500 square feet. Which one is more economical? I'm going to do A first. I have $33.50. 18M, 18,000. So we got basically $1.86 per 1,000. Product B is $25.95. 7.5 M, costing us $3.46 per thousand. So A is more economical. And we probably, could have looked at that and automatically said, yes, we know that A is going to be more beneficial and cost less for us. With problem number 18, the recommended application rate for a granular insecticide is 5 pounds per thousand. It comes in 25-pound bags. How many bags will it take to treat an acre? So we're going to go ahead and do 5 pounds times the 43,000. We're just rounding up the 43,000, the acre, rounding it up. So we're going to need 220 pounds of the insecticide. 5 pounds per thousand equals X over 44. 1X equals 220. X equals 220 pounds. We're going to divide that by our 25 pounds. And we're going to need 8.8 bags. If we went ahead and used, instead of using 44,000, if we did go back and do, 43,560, it would take a little less. You're going to use about 8.7 bags. 19, the recommended pesticide application rate may be expressed in pounds of active ingredient per acre. If a 5% granular 5G insecticide is to be applied at the rate of 5.5 pounds of active ingredient per acre, how many pounds of the granular material should be applied per acre? We got pounds, active ingredient per acre, percent AI. So here we have over 5.5 pounds over our 5%. We state that in 0.05%. We have 110 pounds. Or we can actually state that like 5 over 100. 0.5 over X, do the cross multiplication, still gets 110 pounds. Problem number 20. Somebody's got the TV on, don't they? Y'all watching the Olympic trials? Problem number 20 states an emulsifiable concentrate E or EC, that's how it's written on the labels. Formulation is used to treat half-acre turf. The recommended application rate is 4 pounds active ingredient per acre, and the formulation contains 2 pounds active ingredient per gallon, stated as 2E or 2EC on the label. How much pesticide is needed to spray the area? So kind of a long formulation here. Over pounds active ingredient per gallon multiplied by your area. Which is going to be in acres. Gives us our gallons of pesticide to be applied. And so the actual written out equation is a lot longer. So, but we have our 4 pounds or 4 pound divided by our 2 pound. basically 1 gallon. 4 times 1, 2 times 2, divided that. So we need a gallon of pesticide to spray the area, a half-acre turf. Problem number 21. A superintendent plans to seed a new green. The seeding rate's 1 pound per thousand. The green is not perfectly round. Diameters differ. To determine the average diameter of this irregular circle, the superintendent measures the width at several points. The diameters measures are 72, 67, 69, 68. How much is necessary to establish the green? And so basically, what they're talking about there is like, the green is not perfectly, it's not perfectly round. It's probably, looking something like that. And so they take these measurements, and they're like run across like that. And I know the math may not match to how I'm drawing it, but that's basically what the superintendent's doing. And so he's got one that's, 72, and he's got that one at 67, 69, 60, 68, and then 74. But you get the gist. It's a little different. My lines are a little shorter and longer than they need to be for certain ones. But they add all these up. So you got 72, 67, 69, 68, 74 is 350 feet. There's 1, 2, 3, 4, 5. So 5 into 350, we have an average of 70 square feet. Well, we know that the radius is half the diameter. And so running this based right. R F D 70 divided by the 2, so we have 35 square feet for our radius, because 70 is our diameter. And so when we have that, we can take IR square 3.14 times 35 times 35. Gives us basically 3,800. Do that math in the calculator real quick. Yep. 3,846.5 square feet is what we're establishing there for with the diameter. And so let's see, necessary. We have our square footage. So basically he's going to need just, less than 4, because we got 3,846 square feet for that green. It's 1 pound per thousand. So just a hair shot of 4 pounds. Next problem. A lawn is to be established vegetatively. The sprigging rate is 4 bushels of stolons per 1,000 square feet. Backyard is 90 by 150 feet. The front yard is 90 by 50. How many bushels will it take to sprig the lawn? So we got front and back. 90 times 150. Yeah, the front. 90 times 50. Do the math on those. We have 13,500. Here we have 4,500. You add those up, you've got 18,000 square feet. It's 4 bushels per 1,000. It's 4. So basically, let's take that off because that gets a little confusing when we say that. I like just putting the M there again. So it's going to be 4 bushels per 1,000. We actually have 18 1,000 blocks represented by the M. So the 4 times the 18, we basically need 72 bushels. All right. Problem number 23. A new lawn is to be seeded. The landscaper can buy an athletic field seed mix in 4-pound boxes that cost $12 each. The same mix is also sold in 50-pound bags for $85, which would be cheaper. So again, calculating how much money we're going to save. Box, it's $12, and we are getting 4 pounds. Basically, $3 a pound. The bag, 85, 50-pound, $1.70 per pound. And we should have known that by just looking at it. We're going to go with the bag always. Problem 2-4. Using the answers obtained in problem 23, determine how much money the landscaper would save by purchasing bags instead of the smaller boxes. So now we're just calculating the money. The lawn contains 40,000 square feet. The seed rate's 3 pounds per 1,000. So we set up the math problem like this. Seed 3 pounds per 1,000. We have 40,000. Was 120 pounds. Actually, we got the $3 from the previous math problem. $3 minus the $1.70. That's our box. It's our bag. And so that is $1.38 difference right there. And $1.30, my fault. And so $1.30, that was 120 pounds. We're actually saving around $156 purchasing it in the bags. Problem 25. A southern lawn is to be overseeded with ryegrass. The overseeding rate is 15 pounds per 1,000. The ryegrass seed costs $1.50 a pound. How much will it cost to overseed 20,000 square feet? So we have 15 pounds, 20 M, it's 300 pounds of seed, 300 pounds times $1.50. That's the price per pound. 450 bucks. All right. Problem number 26. A superintendent is preparing a report on irrigation costs for the Green Committee. She needs to know what percentage of the maintenance budget was spent on water. Her records for the past year show that the water bill was $38,600. The total maintenance budget for the whole project was $772,000. So basically, her water bill 38,600 I'm going to divide that by the total maintenance budget. 0.0, basically 5%. Problem number 27. Professional turf managers are able to buy turf supplies at wholesale prices. The general public, of course, pays higher prices. For example, the wholesale price for a bag of fertilizer is $20. The retail price is 30. What percentage is a retail markup? So wholesale. $30 minus 20. So it is $10 more. $10 divided by the 30 of the retail is 0.333. It is a 33 1/3% markup. Problem number 28. The homeowner wants 5,000 square foot of sod installed. Turf manager pays 20 cents a square foot for the sod. What will the manager charge the homeowner for the sod if he chooses to add 50% to the price he paid for it? So we got 5,000 square foot times 20 cents. It's going to cost $1,000 plus 50%. 1,000 times 50% is $500. So charging them $1,500. Problem 29. A person in the lawn care business has fertilized and mowed a lawn. The wholesale cost of the fertilizer used is $50. It took her 2 hours to fertilize and mow. How much should her bill be? Well, she's going to add 50%. It took her 2 hours. Let's do $50 plus the 50%. And that's, 50 plus 25. So we got $75 for the fertilizer. It took her 2 hours. And really, it doesn't state it here on the slide, but her labor rate is $45. Way too cheap. So she's at $90. And we're going to add the 75. So her bill is $165. Doesn't have the $45 labor rate down there. My fault for that. 30. Turf grass problems are solved in exactly the same manner when metric units are used. For example, a certain pesticide applied at the rate of 60 milliliters per 1,000 square meters. The site is 64 meters by 55 more meters, or 55 meters wide. How much pesticide is needed to treat this area? 64 times 55. We have 3,520 meters squared. Yeah, 60 mLs, about 100 meters squared, solving for X over the 3,520 meters squared. X, 100X, whatever the 60, I got 60 times 3520 is 211, 200,000. X is 2,112 milliliters. We got just a couple more, guys. I know I rushed through these, but to get over every single problem within the 50 minutes, we gotta hustle and bustle. So conversions to and from metric measured are necessary. For example, it states a journal that 49 kilograms of nitrogen per hectare is a recommended fertilizer rate. How many pounds of nitrogen per thousand is this equivalent to? And so a hectare is basically we're going to figure it out 2.47 times the 43,560. So it's 107,593.2 square feet. We have 49 kilograms, equivalent to 49 times 2.2 pounds. $107.8 pounds. So basically, divided by the 107.6 thousand 1.00 is 1 pounds of nitrogen per thousand. So math problems that the turf manager faces are relatively simple, and their solutions require only basic arithmetic skills and some common sense. Accuracy is essential when the turf manager calculates the numbers for amounts of fertilizer, pesticide, and herbicides. And pricing math problems helps to develop the necessary math skills. And again, always check your answers. So, and that is the math problems.
Eric the Turf Teacher Jones. Oh, yeah! Teaching you life lessons, business strategies, and leadership.
Let's grow together.